In 8.6, we are solving rational equations, and the easiest way to do that is just to get rid of all the fractions by multiplying everything by the least common multiple. The least common multiple of all the denominators, which is the least common denominator. We also need to make sure that we exclude any solution that would produce a denominator of 0. So if you get a solution and it makes the denominator 0, it doesn't work. Okay, so on number 1, let's first identify the LCD. So we know that 10 and 5 both go into 10, and then we also need to account for the x plus 1. So we're going to take this whole equation and multiply it by 10 times x plus 1. So in the first fraction, 9 over 10 times the LCD, the 10s would cancel, and we would be left with 9 times x plus 1. Okay, we need to make sure that we include the negative sign for the second fraction. X plus 1 would cancel, and we're left with 2 times 10. And on the other side of the equal sign, 10 divided by 5 makes 2. We also have the 2 that was already in the numerator. And we just multiply those by x plus 1. Distribute and simplify. We're going to distribute a 4 to the parentheses on the right. Okay, so we also have to check our answer. We're not worried about denominators that don't have a variable, because those obviously don't equal 0. So over here, if I plug in 3, 3 plus 1 is 4, which is not 0. So as long as the denominator doesn't equal 0, then your solution works. For number 2, our LCD is going to be, so 2 and 10 both go into 10. And we also need to include m plus 3. Okay, so first fraction, m plus 3 cancels out, and we're left with 2 times 10, plus second fraction, we have 10 divided by 2 makes 5, so we have 3 times 5 times m plus 3. And then on the other side, the 10s cancel out. We're left with 19 times m plus 3. 20 plus, I'm going to distribute a 15 to the m plus 3, 15m plus 45 equals 19m plus 57. 15m plus 65 equals 19m plus 57. I'm going to move all the variables to the left. We get negative 4m. I'm going to move the 65 to the right. That makes negative 8. So m equals positive 2. And if we plug it in here, that does not create a 0 denominator. So m equals 2 works. Okay, on number 3, we should probably factor first so we can tell what the LCD is. 2p plus 1 over p plus 4 times p minus 2. Everything else is already factored. So our LCD looks like p plus 4 times p minus 2. So we're going to multiply everything by the LCD. Okay, in the first fraction, both binomials cancel out. P plus 4 and p minus 2 go away, and we're left with 2p plus 1 plus, in the second fraction, the p plus 4 cancels out. We're left with 2 times p minus 2. And on the other side, p minus 2 cancels out, and we're left with 1 times p plus 4. Okay, so checking the denominators. So let's try this a little differently. What denominators would not work? Well, negative 4 would make that 0, so that wouldn't work. Positive 2 would make that 0, so that wouldn't work. And then a repeat, negative 4, positive 2. So the only denominators that, or the only values for p that wouldn't work are negative 4 and positive 2, and that's not what we got, so our answer works. Okay, so we factor first, and then we could tell that the LCD is z plus 1, z minus 1. So that's what we're going to multiply everything by. First fraction, z plus 1 cancels out. We're left with 2 times z minus 1. Second fraction, don't forget the negative. Z minus 1 cancels out. We're left with negative 1 times z plus 1. And in the last fraction, they both cancel out, and we're left with negative 2. So we end up with z equals 1. Then we check our answer. So z equals 1 is fine here, because plugging in 1 makes 2. But it does not work here. 1 minus 1 is 0. You're not allowed to divide by 0. So this doesn't work. And we have no solution. On the back we have a couple of mixture problems that are word problems. So Mike adds 70% acid solution to 12 meters of a solution that is 15% acid. How much of the 70% acid solution should be added to create a solution that is 60% acid? So you're going to take the concentration and multiply by the amount. So he starts with 70% of something, so that is 0.70. And we don't know how much there is, so we're going to multiply that by x. And he's mixing that with a 15% solution. And we know that there is 12 milliliters of that. Mixing these together makes a solution that is 60%. And then we have to multiply by the amount. So if we had 12 milliliters mixed with X milliliters, the total amount at the end should be X plus 12. 15% of 12 is 1.8. 60% of 12 is 7.2. 0.1x equals 7.2 minus 1.8 is 5.4. We multiply both sides by 10 to get x equals 54. Let's go back and check the question. They want to know how much of the 70% acid solution. Well, 70%, we had x of that, so that's our answer. Whatever x is, that's what they were asking for. So it's 54 milliliters. And number 6 is the same type of problem. At a health food store, 3 pounds of dried apples that cost $1.80 per pound are mixed with dried banana slices that cost $2.10 per pound to create a mixture that costs $1.92 per pound. How many pounds of banana slices were used? So we took 3 pounds and those were $1.80 per pound. And we mixed with dried banana slices. We don't know how much. We know what they cost, we just don't know how many pounds. And at the end, well, the amount we had was 3 pounds plus X pounds, and the price of it was $1.92. Alright, $1.92 is closer to $1.80 than it is to $2.10. So because this price is closer to that than it is to that, I'm going to say that there is more of the $1.80. There's more dried apples. So we should expect an answer that is less than 3. So 3 times 1.8 is 540 plus 2.1x equals 1.92 times 3 is 5.76 plus 1.92x. Okay, moving all the x's to the left, we get 0.18x equals 5.76 minus 5.4 is 0.36. X equals 2. So what did x represent? It represented how many pounds of bananas we had. So the answer is 2 pounds of banana slices.